Okay, this is the second try at this set of notes. There was a typo on the very last slide of the previous video, so it's been removed, and this one has been uploaded in its place. So again, we're talking about solving quadratic equations. Quadratic equations are any equation that comes in the form ax squared plus bx plus c equals 0. So there are basically three parts to this set of notes: solving quadratic equations when using square roots, talking about the discriminant, and then solving with the quadratic formula. So when we solve a quadratic using square roots, that happens essentially in two situations. We would use this approach anytime b in this equation is equal to 0. In other words, there would not be a term with an x. It would be something along the lines of ax squared plus c equals 0. We would then solve that using square roots. The other time that we will use this is when one side of our equation contains a binomial squared. The time we've seen this so far in this chapter is basically when one side looks like vertex form. So we're going to break this set of this chunk of the notes into two parts. We're going to do 6 examples involving solving by square roots when b equals 0, and then we will do a few examples where there's one side is a binomial. So when we talk about problems where b equals 0, we're talking about equations that look like this. Now what we need to do is we need to isolate the x squared term. We need to get that by itself. So our first step in this problem would be to add 64 to each side to get x squared by itself. This would result in the equation x squared equals 64. Now, just like any other equation, when we solve this, we're trying to get x by itself. It just happens we have to get x squared by itself first. And the reason for that is our next step is going to be to take the square root of each side. Square roots and x squared, an exponent of 2 and a square root, are opposites, just like multiplication and division, addition and subtraction. So those would cancel each other out and leave x. On the other side, the square root of 64 is either positive or negative 8. Now what this is telling us is that this particular equation has two solutions, either x equals positive 8 or x equals negative 8. On letter B, that equation is already set up to be square rooted. X squared is already isolated. It is already by itself. So we take the square root of each side. Now when we do that, again, the exponent and the root will cancel each other out on the left side, leaving x. We will have a positive and a negative root, so we use the plus or minus notation. And then we've taken the square root of 80. Well, 80 can be broken down. It is 16 times 5, which means our answer would be 4 root 5. Again, your yellow calculators do this step already for you, but you need to know what the calculator is doing. So our two answers for that equation, if we broke them up, and you don't necessarily have to, would be x equals 4 root 5 or x equals negative 4 root 5. On letter C, this would be a two-step equation before we take the square root, because again, we're trying to get x squared by itself. So our first step would be to subtract 7 from each side of the equation, which would give us 3x squared equals 48. Then we would divide each side by 3 to get x squared by itself. A lot of you on the homework so far are forgetting that we're supposed to have x squared completely by itself before we take the square root. So then we would take the square root of each side, which would give us x equals plus or minus 4. So again, what that's telling us is that either x equals 4 or x equals negative 4. And you don't necessarily have to break those up. You could just circle plus or minus 4 and you would be fine. Now in class we had those three and then we had you try 3 examples. Obviously you're not here to try them. So instead, here are the next 3 examples solved in a similar fashion. Now again, with any quadratic equation, we're going to have to make sure that when we start it equals 0, or at least we need to isolate that x squared term. So if we look, there are 2 x squared terms in letter D, one on each side of the equation. So we need to add x squared to each side in order to combine those terms. Now while we're at it, since we're going to be solving for x squared anyway, we might as well move the 15 to the right side to get the x squared term by itself. That would give us 3x squared equals 27. We still have not solved for x squared, so our next step is to divide each side by 3, which would give us x squared equals 9. And then we would take the square root of each side, which would give us x is plus or minus 3. On letter E, we would start by adding 45 to each side, which would give us 4x squared equals 45. This we would then need to divide each side by 4 to get x squared by itself. So x squared would equal 45 over 4. Now notice I did not turn that into a decimal. Unless it is a real-world word problem, you should never be using decimals in Algebra 2. So we'll take the square root of each side. Keep in mind, if you put that in the calculator, you need to do the square root of the top over the square root of the bottom, or else it's going to give you the wrong answer. So that will tell you that x is plus or minus, and the calculator won't tell you plus or minus. You have to remember that. Root 45 reduces to 3 root 5, and square root of 4 is 2. So 3 root 5 over 2, plus or minus. On the next problem, this is similar to letter D, in that we have to get the x squared term by itself, so we subtract 3x squared from each side. And while we're at it, we might as well move the 12 to get the x squared term alone. So that would be 7x squared equals 140. Then we divide each side by 7 to get x squared by itself, which would give us x squared equals 20. Finally, we take the square root, which would give us x is plus or minus, and root 20 reduces to 2 root 5. So that takes care of square roots when b is equal to 0. Now we're going to take a look at some examples where we have a binomial squared. Now the situation is, instead of solving for x squared like we did in examples A through F, we are now going to solve for the parentheses squared. So we want to get rid of everything except the parentheses on one side. Now in letter G we already have that. So that allows us to talk about what we will do at that point. What we do at that point is we take the square root of each side. That will cause the exponent and the root to cancel each other out. And what would be left would be what's inside the parentheses. So x minus 3 equals, and then the square root of 49 is plus or minus 7. Now the major difference here is what happens next, because we have to then continue and solve for x. So then we would add 3 to each side. Now notice I'm not adding 3 directly to 7 right away, because that's not 7. That is plus or minus 7. So x is equal to 3 plus or minus 7, meaning there are two solutions. 3 plus 7, or 10, and 3 minus 7, which would be negative 4. Alright, on to letter H. Now here you'll notice the parentheses are not by themselves. So the first thing you have to do is divide each side by 3. That would give us x minus 4 quantity squared equals 9. Then we would take the square root of each side to get rid of the parentheses. Again, the exponent and the parentheses, or the root and the exponent will cancel, leaving x minus 4. The square root of 9 is positive or negative 3. Then we add 4 to each side to finish solving for x. So x would equal 4 plus or minus 3. Now what that tells us again is that we need to break that up into 4 plus 3, which would be 7, or 4 minus 3. I should write that as x equals 4 minus 3. Now we're waiting on the computer. Okay, 4 minus 3, which would be 1. So your two answers there are 7 and 1. Next up, we're going to move into two more of these examples. So again, we're going to isolate the binomial. We did these in class as examples, and then I walked around and checked. So we add 3 to each side, which gives us quantity x plus 1 squared equals 3. And then we take the square root of each side to get rid of the parentheses. Now, this is the first one we've had where the right side wasn't a perfect square. So on the left side, the parentheses will cancel. But on the right side, it just stays root 3. So we have x plus 1 equals plus or minus the square root of 3. Now, in a way, that makes this easier, because then when we solve, by subtracting 1 from each side, 1 and root 3 are not like terms. So all we have to do is write -1 plus or minus the square root of 3. And we can leave our two answers paired up with each other based on that plus or minus symbol. All right, on to letter J. This one is a two-step solving process before we take the square root. We're going to add 21 to each side, which would be 3 times the quantity x minus 2 squared equals 15. Then we are going to divide by 3 to isolate the parentheses, which would give us x minus 2 squared equals 5. And then we're going to take the square root, which gives us x minus 2 is plus or minus the square root of 5, because again, that doesn't reduce. Add 2 to each side to finish the solving process, and we get x equals 2 plus or minus the square root of 5. And it's not going to get any better than that. Now, from there, we are moving into talking about the next piece of this lesson, which is the quadratic formula. And along the way, we're going to talk about a certain part of it. You should remember from Algebra 1 that if we have a quadratic in the form ax squared plus bx plus c, where a, b, and c are real numbers, equals 0, then x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. This formula is known as the quadratic formula and is a large piece of Algebra 1. Now, this number underneath the root is usually enforced in Algebra 1. That is known as the discriminant. And the reason it's known as the discriminant is because it discriminates between the 3 different types of parabolas. In a parabola, you can have 3 situations. There can either be 2 x-intercepts, meaning it crosses the x-axis 2 times. You can have 1 x-intercept, which would be when the vertex of your parabola is on the x-axis, or it could have no x-intercepts, in which case the parabola never crosses the x-axis. The discriminant is able to tell you which of those 3 situations you have. It discriminates between those 3 situations. Now, it is worth noting that the remainder of the equation is something that should look very familiar to us, negative b over 2a. Negative b over 2a, that is the axis of symmetry from when we graphed and talked about the properties of parabolas back in section 4-1. Now, let's talk more in detail about the discriminant. The discriminant, which is the value b squared minus 4ac, just the number underneath the root, not the root itself. What that does is that tells us the number and type of roots, of zeros, of solutions, of x-intercepts that our equation has. Okay? And again, all 4 of those words mean exactly the same thing. Roots, zeros, solutions, x-intercepts. No matter which one you're asked for, you can find those using the quadratic formula. So if the discriminant, which again is b squared minus 4ac, is greater than 0, now what does that mean? That means if it's positive, then your graph crosses the x-axis in 2 places, meaning that there are 2 real solutions to that equation, 2 real roots, 2 real zeros, 2 x-intercepts. If b squared minus 4ac, the discriminant, is equal to 0 or neutral, then the vertex of your parabola is on the x-axis, which means there's only one solution, one root, one x-intercept. Now that particular root, and we'll learn this at a later point in time, is then known as a double root or a double solution, because in theory both factors of your parabola, if you factored it, would have the same solution when you applied the zero product property. Finally, if the discriminant b squared minus 4ac is less than 0, negative, then that parabola does not cross the x-axis. It does not have any real solutions. It does, however, and we will get back to this later in the year as well, have two solutions. They are just not real numbers. They're known as complex solutions, and that will also be discussed in a later lesson. For now, we're just going to need to be able to state that there are two complex solutions if the discriminant is negative. So let's do some examples with the discriminant. Our process here when we solve with the quadratic formula is a three-step process in this course. The first thing you always do is find the discriminant. Again, that value is b squared minus 4ac. And you're going to then take that value, the discriminant, and a and b, and plug into the quadratic formula, which again is negative b plus or minus the square root of the discriminant over 2a. So you're going to plug your discriminant value in underneath the root, b there, a there, and then you'll simplify. There should always be two answers if the discriminant is not equal to 0. So the first problem type you're going to have to deal with is you're going to have to be able to find the value of the discriminant and use it to describe the type and number of roots, solutions, zeros, x-intercepts. So what we do is we make sure the equation is equal to 0, and all of our examples of this in these set of notes are equal to 0 to start with, so we don't have to worry about that. Then we're going to identify the a value, the b value, and the c value. Now for our first equation, a is equal to 1 because there's no number in front of x squared, b is equal to 6 because there's a 6 in front of x, and c is equal to 9 because 9 is the number that doesn't have a variable attached to it. We are then going to plug into b squared minus 4ac, which is the value of the discriminant. That would be 6 squared minus 4 times 1 times 9, which would be 36 minus 36, or 0. Now we said on the previous page, if the discriminant is equal to 0, that means we have the number and type would be one real solution. It's all about the sign of the discriminant. If it is positive, there are two real solutions. If it's negative, there are two complex solutions. And if it is neutral, if it is 0, there's one real solution. Same thing for b. Our value in front of x squared is 2, so a equals 2. Our number in front of x is negative 5, so b is negative 5. And our number that doesn't have a variable attached to it is negative 14, so c is negative 14. b squared minus 4ac would be negative 5 quantity squared minus 4 times 2 times negative 14. That would be 25 plus 112. 25 plus 112 would give us a discriminant value of 137. That is a positive number, which means we have two real solutions. Okay. A couple more examples of this, and then we'll do some quadratic formula solving, and we'll be done. So again, these are all equal to 0, so we're just going to go straight in here. And again, we did most of these in class to prove our understanding. So we identify a, b, and c, plug into b squared minus 4ac. That would be 64 plus 192, which would be 256. That is a positive number, so that would be two real solutions. The speed here is going to be relatively quick. On letter D, A is 1, B is negative 6, C is positive 10. B squared minus 4AC would be negative 6 squared minus 4 times 1 times 10, or 36 minus 40, which would be negative 4. It is a negative number, so that means we have two complex solutions. On letter E, A is 2, B is 5, C is 4. So B squared minus 4AC would be 5 squared minus 4 times 2 times 4, which would be 25 minus 32, or negative 7. Again, if it is negative, that tells us we have no real solutions and two complex solutions. We'll come back to that later in the year. Letter F is the first one we've had where A was negative, but it doesn't change the process at all. We identify A, B, and C, and we plug into B squared minus 4AC. So that would be negative 5 squared minus 4 times negative 1 times negative 2. That would be 25 minus 8, or 17. That is a positive number, so we have two real solutions. Next up, we're going to start solving using the quadratic formula. Now remember, our first step in that process is still going to be to find the discriminant. See, it says it right there in the directions. Find the discriminant first. So again, we need to make sure that our equation equals 0. It does. Then we identify A, which is 7, B, which is negative 2, and C, which is negative 5. We plug into the discriminant, B squared minus 4AC, which is negative 2 squared minus 4 times 7 times negative 5. That would be 4 plus 140, or 144 for the value of the discriminant. Now notice I'm not writing that there are two real solutions. I know there are, but that's not part of what I'm being asked, so I don't need to answer that. Instead, what I'm going to do at this point is move into the quadratic formula, which again is negative b plus or minus the square root of the discriminant over 2a. B is negative 2, so the opposite of b would be 2. Plus or minus the square root of the number that we already found for the discriminant, 144, over 2 times a, which is 7. So that means x is 2 plus or minus the square root of 144, which would be 12, over 2 times 7, which is 14. Now there are no roots in this answer, so we are expected to break that into two separate answers. 2 plus 12 divided by 14, or 2 minus 12 divided by 14. We would then simplify each of those in turn. 14 over 14 would be an answer of 1 for the first solution. And on the second solution, we'd have negative 10 over 14, which does reduce. It does not divide evenly, but it does reduce to negative 5 over 7. Let's do another one. Already equals 0, so we identify A as 1, B is 8, C is 16. That means the discriminant, b squared minus 4ac, would be 8 squared minus 4 times 1 times 16. That would be 64 minus 64, or a discriminant value of 0. Then we go, and we had a lot of people panic at this point. We still do the same thing. We're going to go plug that into the quadratic formula. Negative b plus or minus the square root of the discriminant over 2a. B is 8, so negative b would be negative 8, plus or minus the square root of the discriminant, which is 0, over 2 times 1. That means x is negative 8 plus or minus the square root of 0, which is 0, over 2. Now notice this is why when the discriminant is 0 there is only one solution. Because it doesn't matter whether we do negative 8 plus 0 or negative 8 minus 0. That has no effect on the top of this fraction. Essentially that plus or minus just drops out and leaves negative 8 divided by 2 which means x equals -4. Now technically that is what is known as a double root or double solution, because both -8 plus 0 divided by 2 and -8 minus 0 divided by 2 are -4. So that answer would technically occur twice. But this is why there's only one solution when the discriminant equals 0. 2 examples to go. Now C is different from A and B in that it does not already equal 0 to begin with. So before we start doing anything else, we have to make it equal 0. And I've told you before, we want our x squared term to be positive. So if we look, 4x squared is already positive. So instead of moving everything to the right, we're going to move everything to the left. So we're going to subtract 5x from each side. Notice I'm writing that underneath 7x because those will combine. And we're going to subtract 4, which will not subtract from anything, so I'm writing it off to the side. That means we are looking at the trinomial 4x squared, because we bring that term straight down, minus 12x, which is -7 minus 5, minus 4 equals 0. Now we could divide everything by 4 at this point, but technically that would not be the same parabola, and we don't really need to. So we're just going to leave it with those numbers. Even though everything is divisible by 4, we're just going to leave those numbers. You could divide by 4 and it would not change your final answer. You should get the same answer either way. So what we do is we identify that A is 4, that B is -12, that C is -4, and we do the value of the discriminant, b squared minus 4ac. So -12 squared minus 4 times -4. That means our discriminant is 144 plus 64, which would be 208. All right, so we then plug into our quadratic formula, -b plus or minus the square root of the discriminant, all over 2a. Again, the opposite of b would be +12, because it's -12 up here, so it would be +12 down here, plus or minus the square root of 208 divided by 2 times 4. So x is 12 plus or minus the square root of 208, which does reduce. 208 is 16 times 13. Let me double check that real quick. I'm pretty sure that's right. Yep. So that would reduce to 4 root 13, because the square root of 16 is 4 over 8. Now we would be done here, but you notice that 12, 4, and 8 are all divisible by 4. If we had divided by 4 up here, then we would have 3 root 13 and 2. We're supposed to then divide all three of these numbers by 4 now instead of up there, which would give us 3 plus or minus the square root of 13 over 2. I don't ever want a decimal on a problem that is not a real world word problem. Okay, finally, up here this does not equal 0, so we need to move the 10. We're going to subtract 10 from each side of that equation. That will give us x squared minus 2x minus 10 equals 0. A is 2. B, I'm sorry, that's not correct. I'm trying to change and do too much at once. A is 1. B is -2. C is -10. Discriminant, b squared minus 4ac would be -2 squared minus 4 times 1 times -10. Which would be 4 plus 40, or 44. That means x is the opposite of b plus or minus the square root of the discriminant, all over 2a. Same steps we've been doing in the last 3 examples. -b would be 2 plus or minus the square root of the discriminant, which is 44, over 2 times 1. So x would be 2 plus or minus 2 root 11, because this reduces to 2 root 11. It's 4 times 11, and the square root of 4 is 2, over 2. Now notice that everything here is divisible by 2. So we are expected to divide everything by 2, which would give us 1 plus or minus 1 root 11 over 1. But there's a couple 1's in there that we don't have to write. The only one we have to write is the one that's by itself. We don't need the 1 in front of root 11, and we don't need the 1 in the denominator. So we would get 1 plus or minus the square root of 11. The final slide of these notes is a word problem. Now this word problem is talking about projectile motion, and specifically projectile motion in feet per second. Now when we have an equation in feet per second, we can generalize the equation and always use this equation right here, which is h equals negative 16t squared plus the initial velocity times t plus the initial height. It says it right up here. V0 is the object's initial velocity in feet per second. H is the height in feet. T is the time in seconds. And h sub 0 is the initial height in feet. This is a common thing to have happen on a standardized test, is they will give you an equation and explain the equation. So you can't get scared when you see the wall of text. From there, what we are going to do is read the problem, and we have to pick out 3 values. We're going to find 3 values to replace: h, initial velocity, and height. Okay? So it says a basketball player shoots the ball as the clock buzzes. The ball leaves the player's hand 6 feet above the ground. That means that that is your initial height. So we're going to plug that 6 in for h0. That ball also above the ground, it has an initial velocity of 48 feet per second. So that's pretty straightforward. That's your v sub 0 is 48 feet per second. So we're going to plug in 48 here for v sub 0. He makes the basket, and the ball lands on the floor. Now remember, the floor would be h equals 0. Okay? How long is the ball in the air? So that's saying, what is t when h equals 0? That's what that question is asking. Now notice it tells you to round this problem off, which means we are going to give a decimal answer. I know that makes some of you so happy. Okay? We're going 1 decimal place on our answer. Okay? So we plug in what we have. Okay? Some of this stuff is not going anywhere. Okay? We're plugging in 6 for the initial height. We're plugging in 48 for the initial velocity, and 0 for the height, because that's what we're trying to solve for. Hey, look, that is a quadratic equation. It's what we just finished solving. So we're going to take that exact same process. A is negative 16, B is 48, and C is 6. We're going to find the discriminant. B squared minus 4AC would be 48 squared minus 4 times negative 16 times 6. Now that's a pretty big number. 48 squared is 2,304, and negative 4 times negative 16 times 6 is 384. When we add those together, we get 2,688. Now a quick check. We're going to find out that 2,688 does not have a perfect square root. So we're going to come in here and do the exact same thing we did on the previous 4 examples. We're going to plug in A, B, and the discriminant. That would be negative 48, which is the mistake I made in the first video. I only had 48, not the opposite of B, which would be negative 48, plus or minus the square root of 2,688 over 2 times A, which is 2 times negative 16. We're going to move up here now. That means that x is negative 48 plus or minus that ugly square root, because even our calculator can't reduce that. That's how we know we're going to have a decimal, over negative 32. So that is 2 possible answers. Negative 48 plus the root of 2,688 over negative 32, which we'll put in the calculator in a minute, and negative 48 minus the square root of 2688 over negative 32. So there are 2 solutions, but we're not going to use both of them. Alright, so using the fraction button on our calculator, we are going to enter each of these into the calculator. Now what's going to happen is it's going to spit out a big, long, ugly decimal, negative 0.120185175. So we're going to round that off like the problem told us to and get negative 0.1 seconds. Then we do the other one, negative 48 minus the square root of 2688 over negative 32, and round that off to one decimal place. It's 3.120185175. So 3.12 would round down to 3.1 seconds. Now this is where we have to consider the context of the problem. In this problem, when the player shoots the basketball, it's already 6 feet off the ground. So the reason that this one is here is if we graph the entire parabola, it has an x-intercept on the negative side of the y-axis. So that's not within the context of this problem. The domain of this problem is only positive time. Time in this context is not negative, which means we are not using our negative answer. The answer we are using is 3.1 seconds. So we would say the ball is in the air for 3.1 seconds. And that would be the answer that we would provide for this word problem. Again, a decimal is acceptable because it is a real-world word problem. Okay, hopefully I got it right this time.